All right, we're looking at solving algebraically now, part one. Now, first of all, the method that we've been using up to this point has been solving graphically, and most of our answers have been kind of best guesses. And there's got to be a method to find a more exact solution, and that's exactly what the algebraic method offers. So first of all, let me give you the big picture. We're really using substitution. Okay, substitution means that you take one equation and you kind of solve for one of the unknowns, either x or y, and then you substitute that into the other equation. And so that's really the key. The substitution is really the key, no matter how complicated these equations might look. So let me start with my first example and show you kind of how it works. Okay, so I got y equals negative 2x squared plus 10. Now notice this is a quadratic equation, okay, because it's got the x squared in it. And the other one I've got is x minus 2y equals negative 15. Now this does not have anything squared, so this is actually linear, this second equation. So now what I'm going to do is I'm going to try to make some kind of a substitution. And what I'm going to do, this one just seems the easiest. If y equals all of this stuff, then why can't I take this stuff and put it in for the y in this equation here? I mean, to me, that just makes the most sense. This might be the easiest approach to use. So I'm going to rewrite the second equation, and I'm going to make that substitution now. So I'm taking y out, and in its place, negative 2x squared plus 10. And that equals negative 15. So now look at what you have. You have one equation with only x's in it. We know we can solve that, so we know we're on the right track. So I'm going to get rid of the brackets here, so expand them out. So that's 4x squared, and then negative 20, and then equals negative 15. And I like the positive x squared term, so I'm going to keep the terms on the left side. And next one would be the x. And I'm just going to move, bring that 15 over, so I'm going to add 15. So this is now minus 5. Okay. Now when you get here, you totally have your choice in what method you might want to use. Whether you can, I usually go for factoring. To me, that's the easiest. If I can factor this thing, then I'm right away there. But you might want to use a quadratic formula. I mean, there's absolutely no reason to use one method over the other. I just happen to have had it factored here, so that made it easy for me. So 4x times x gives me 4x squared. And now I need a number times a number to make negative 5 in such a way that they add up to positive 1. I see in my notes here that I put the positive 5 here and a negative 1 here. Of course, if I were to just expand this out, I would get positive 5x's and negative 4x's. So that's what I'd want to make positive 1x. So it looks like it's working. And so it looks like I have two solutions. Now the best way to solve these, if you find it difficult to spot the solution, this one isn't too bad. I go, yeah, x could be 1. That'll make that 0. But if you can't see it, just do this. We would like 4x plus 5, okay, the stuff in the brackets, we would like that to equal 0, please. So now I'm just going to go ahead and solve that. So I'd subtract the 5 over and then divide by 4. And so here's my other solution, negative 5 over 4. Okay, so it looks like I got two solutions here. Now, how do I finish the job? Well, you have basically two equations to go back to and make some substitutions. It is preferred you always go back to the linear. Now, that doesn't work if you have two quadratic equations. But if you have a quadratic and a linear, if you have a linear, always go back to the linear equation to find your solutions. Okay, so I'm going to do that. Now, unfortunately, I'm going to have to clear this. So maybe I can do it down the side here. Yeah, let's see what we can do. Okay, so I'm going to have to plug these in separately. If I plug in let's get the ugly one over with first. Negative 5 over 4. So that gives me negative 5 over 4 for x minus 2y equals negative 15. Okay, so to solve this, I think what I would do is I'd probably just multiply everything by 4, just kind of to get rid of the fractions. So 4 times that would be negative 8y, and 4 times this guy should be negative 60. You know, I should have made it negative 4, but anyway, it doesn't matter. Let's add the 5 over. Okay, so if I add 5 over, I get negative 55. And lastly, I'm going to divide by 8. So the y would be, and of course the negative divided by negative, yep, is positive. So one of my intersection points would look like this. I would have an x value of negative 5/4 and a y value of 55/8. Now, I don't think I would have got that by graphing. To me, that's very precise and very accurate, totally correct answer. So now the only other question is, what about when x is 1? And I don't think I'm going to have enough room over here. Let me see here. Maybe I can sort of open up a little window over here and see if I can do that. So I can delete a bunch of this stuff here. And gives me a little bit of room to work. So I'm going to plug in that 1 for x. So 1 minus 2y equals negative 15. And let's bring the 1 subtracted over to the other side. So we'd have negative 16. And then divide by negative 2. So we would have 8. So here's my other solution. When x is 1, y turns out to be 8. Okay? And there you have it. The method of using an algebraic approach to get some very precise, accurate answers. So that's where I'm going to stop at this moment.